Firstly, welcome everyone. My name is David Burkett. I am one of the group directors of WorkingMouse, and also I'm the head of growth. I'm joined with me here today, Chris Pennycuick, who is a senior solution architect. He is an analytics and AI expert in the business.
Good morning, everyone.
Yeah, so I'm your guide and he's your nerd. That is the way that we're running things today. So hopefully I'll be able to translate the technical stuff that Chris pops out into kind of plain English. What we'll do just before we commence, just so everyone knows, the meeting is being recorded, so it can be sent out to everyone who has attended, didn't get to attend afterwards. We won't be providing anyone's details or names on that recording, but it will be reused for editing. We will try and make the session interactive, but I believe if you're on the webinar link, you may not be able to ask questions or interact back. But if you are stuck or have a question, please feel free to raise your hand, and we'd love to have that feedback throughout the session. So we appreciate everyone taking the time to meet with us today. We're going to try and keep it succinct and have you out of here by 12:45, but there is a fair bit of content to get through in this emerging space. So the end goal of what we want to do today is do a 101 on what AI actually is, where it helps, and a simple framework for safe adoption. This topic was actually chosen by our community, so we addressed our LinkedIn followers who all voted for this topic as the top way, the thing that they would like to learn on. So we've specifically designed the content to be around that. It is very much an AI 101 if you've not used AI before, or you haven't been following along, or you're a bit confused about some of the technical terms within what AI is. The agenda that we're going to follow is we're going to cover off first principles. So what is AI? And we'll take you through the reference guide and then explain some key concepts. Follow that, we'll review some use cases around where it helps and how it helps, and how to also measure the impact of AI implementations within your organization. Following that, we'll share with you some of the things that we're doing around our governance structure for AI in regards to policy and training. And then Chris is going to jump on the tools and give us a bit of a technical demonstration of what we've been doing with AI in regards to local AI or private AI. And then if we can, we will open up to a Q&A if anyone can provide any questions in the chat. I'm not sure if you're able to do that. So first things first, what is AI? Now, there's a lot happening in AI at the moment. Everyone's saying there's a bubble. There could be a bubble. We don't know. If you don't have the foundational knowledge, you may make the wrong decision. And this could lead to a lost opportunity or wasted cost. In my mind, it's critical in the next 12 months to ensure that your business has an AI policy or a strategy or a stance. Reason being is that if you're not doing anything, your competition is, and you need to keep up with what is happening in market and the market trends. So firstly, what is AI? Now, AI is, next slide, please, Chris. It's a number of things. At the moment, the AI landscape is playing out around large language models or natural language processing of AI, like ChatGPT, Claude, Gemini, and things like that. There's been significant breakthroughs in the last 18 months. However, AI as itself is actually a lot wider field. So machine learning and deep learning are the core things that have enabled natural language processing through large language models. There was a breakthrough probably the better part of 10 years ago with the concept of deep learning. Deep learning enabled machines to effectively self-improve via a learning algorithm. That happened 10 years ago, and that was the foundation for machine learning to come out of what we call the AI winter, and things to really start gaining traction. On top of this as well, we also have computer vision. So computer vision is when a machine actually interprets a visual object and can recognize that object and then do something with that information. Robotics, everyone knows, and also knowledge and reasoning. Large language models touch on a number of these, but they are all independent fields of themselves. So the next slide talks about the AI versus AGI, and we put a bit of a Zuck versus Musk meme on here. Reason being is they have two very differing opinions around the future of AI. There is a general consensus that something called AGI will be achieved probably within the next decade or so. To explain what AGI is, what I would say is that AGI is the ability for all of the previous AI fields that we just spoke about to be able to self-form and join together. And what that means is that the human brain will effectively be mimicked as AGI. So it can process and do the same things in regards to machine vision, in regards to vision, as into knowledge and processing, and in regards to languaging, effectively mimicking the different areas of the brain. Now, the reason we have Musk and Zuckerberg on the slide here is that these two guys, as everyone knows, have two very differing opinions on the future and outcome of AGI. So they believe that we will achieve AGI. Zuckerberg believes that it will be positive and good for humanity, whereas Musk believes that it is an existential threat to humanity when that is achieved. So if you're after wanting to know what the topic of AI is, and when someone mentions the threat of AI, it's not AI that we have right now, it's the concept of AGI in the future. And then you want to add on to that, Chris?
No, I think you've covered that all really well, Dave.
Yeah, fantastic. All right, so I'll pass over to you to talk about large language models.
Yeah, so large language models are this type of AI, as Dave's talking about, which is really good at working with natural language. It can take your prompt or your query, it can take your words and your sentences, and then predict what is the best response to give back to that. And that language comes back in natural language for you as well. And so that sounds, looks, reads like human language or human speech. And that's really great when processing information or putting together a response given us other pieces of information. And yeah, it excels at tasks such as writing, such as summarizing, and yeah, responding to questions. So what large language models do is this technical word called inference. Essentially, this is the process of taking your query in natural language, converting it to an internal representation, then computing the output and giving it back to you in natural language. So all of that process is what we call inference.
Mm-hmm.
Yes, so it's important to point out, while it may seem a little bit scary or confusing that these LLMs may have personalities, or they may seem to have preferences, or they may align one way or another, this is really just statistical patterns. They don't have intentions, they don't have self-awareness or true understanding. They only appear and often convincingly act intelligent due to their training data. And that's what we've been seeing with the improvements in LLMs recently, is we've been giving them more and more data, so their apparent understanding appears deeper and deeper. But all they're really doing is predicting what they should answer, with. And most of the time, that answer is correct or very close to correct. Sometimes it's not correct at all, but it sounds like it could be correct. And that's something that we'll touch on a little bit later.
Mm-hmm. The training.
Is that the next slide?
Yeah.
Okay. Lots of things go into AI and these LLMs. LLMs, we often just refer to them as models. So that's what I'm going to refer to them moving forward. Now, these models actually come in a number of different sizes. And effectively, these sizes represent its depth of understanding. So the smaller the size, the more shallow the understanding. The larger the size, the more deep, the more intuitively appearing intuitive the response of these models will be. And that's one of the biggest areas of growth that we've seen recently in the last, I don't know, 2 years with these LLMs, is that we've been throwing more and more and more compute or processing at them to train them with not just more data, but to give them more of these weights, more of these parameters, which allows them to have a more accurate response. So,
can you also explain what a model is and the difference between training and fine tuning?
Yep. So, what these big AI players do, such as ChatGPT or OpenAI, I should say, and Anthropic, they go through the big AI training, which is where it will provide these vast amounts of data and knowledge and content to these models, and this trains them and trains their parameters, trains their weights, so that when it's given a prompt or some text, it will then take that, interpret it, process it through all of these parameters to give you a response. So that's training. Training is very, very, very expensive. It takes a lot of compute and a lot of time. And when you look at the amount of compute that someone like Anthropic or OpenAI uses, it's very expensive, not something that the average person can do. You need a lot of money. However, fine-tuning. Fine-tuning is something that is much more accessible. Fine-tuning is where we take a model that has already been trained and we just tweak, just shift these little weights, these little parameters around, and we fine-tune these models so that they respond in a slightly different way, or they understand certain types of inputs better and respond to those inputs better. So what actually happens is, software development is a fantastic example. These models that are developed for software development are actually fine-tuned models on top of these base models. And that's where they're trained or fine-tuned on these large amounts of code of certain languages, and then trained how to output them. Fine-tuning can actually be done using some other platforms that allow you to use cloud GPUs. There's actually services out there specifically that aid in fine-tuning. And it's a whole separate topic to go down how we do fine-tuning, but it is another option that we have.
Yeah, great.
How we end up with all these different types of models.
Yeah. And can you unpack some of these technical concepts for us?
Yeah. Okay. So models, large language models don't respond in words or sentences. They respond in these tokens, and it is a typically a subword, but it can be a whole word. And this is because it makes it much easier for the models to be more accurate. So, for example, here, cat, the 3 letters cat might be one token, while predictable could be broken into several sub-tokens. It's often seen with searching as well. So there's like prefixes and suffixes on words that are very common. Often those suffixes, for example, are dropped off and you just treat that first part of the word as what you're searching for. So this is one area that tokens are really valuable, is we now have one token that represents the core of the word, and then a following token that will reference what correct part of that word then applies in the rest of the sentence. That might be tense, that might be, in other languages, gender. Punctuation also are individual tokens.
And the tokens are effectively what you're consuming when you're using a public or cloud AI service, right? So you're using a certain amount of tokens, either via API or through the context window in your chat. And that's where you can get limited, or costs can actually fly out if you're using too many tokens.
That's correct.
Yeah,
all
so
of your
consumption.
All of your chats that you perform to submit to the LLMs, and all of their responses come through as tokens. And those, yes, those do have a limit, so that we don't use too much. And those tokens are actually what is used to calculate costs.
Yeah.
For these public AI companies.
And can you explain benchmarking and quantization?
Yes. So one of the things that we struggled with initially, but we're getting better at now, is working out how do we work out the intelligence of a model. I shouldn't say intelligence. How do we work out how well, that's right, because it's not actually intelligent, how well a model can respond to questions and understand in depth what it's being asked, and then pull together a response, an accurate response from its knowledge.
Mm-hmm. And these two concepts down the bottom, RAG and MCP, very important terms for understanding what you can use AI for. Can you explain that?
Yes. RAG, which is short for retrieval augmented generation. Essentially what that does is, that is a separate process that will go and fetch content such as like a web search, or it might query a document that you have and provide that to the LLM as part of your prompt. Now, this has, the introduction of RAGs was a huge leap forward for LLMs. We saw that historically they would give misleading, while confident and believable answers, give misleading and incorrect answers, because it was only pulling from its own internal training and weights and its best memory. By using RAG, it's able to go out and query active or real-time data and pull in to its context the current relevant data. And this is really valuable when you're searching a user guide, or you may be wanting to use web search to augment and improve your results.
Yeah, so an example of that is that if you're working within, you add the documents that you want to be RAG'd from, and then ask queries from that document, it's going to give you accurate information rather than hallucination.
Correct.
Yeah,
yeah.
But it's still validated.
It always still needs to be validated, absolutely. But yes, it is much more accurate. And I'm going to give a demo of RAG a little bit later.
Great. And MCP?
MCP is essentially, the easy way to describe this is allowing an LLM to perform API calls. So the model context protocol is like a layer that sits in the middle. It allows interaction between an LLM and a server of a certain API. So there's a set API that model context protocol servers must follow, and allows LLMs to talk to them. And then those model MCPs can do anything that the developer has built them to do, and they will go out and make API calls to whatever their purpose is. So that might be to read files from a file system, that might be to make calls to GitLab or Jira to ask about tickets or information, or it could be, what's another example?
Integrating with the LMS or something like that.
Yeah, exactly, integrating with an LLM.
Yeah, so it effectively links your model up to an external system.
Yeah.
So it can be used and leveraged.
Yeah.
Inbound and outbound as well.
That's right.
Yeah, definitely. Cool. All right. There was a lot of technical concepts on that slide. Sorry, guys, but it's foundational stuff that we're going to move forward through. And we're going to explain some of the different types of models now before we talk about hardware and demonstration.
Yeah. So I won't hold up on these ones for too long, now that we have the foundation. So we've just pulled together a couple of models. Some of them you may have heard of, some of them you may not have. Just to demonstrate some names. Oh, I can't point. Yeah, I can point. To demonstrate some names and how they have different parameters, and then show how they, after being benchmarked with this is one of the most common ones here, MMLU. I won't describe it. And then they get a score. So here we have Llama. This is done by Meta or Facebook. We have the Qwen 3 model, which is done by Alibaba. The DeepSeek version 3, which is done by the DeepSeek org. Mistral Large 2, which is done by Mistral AI. DeepSeek again. Kimi K2, done by Moonshot, and GPT OSS. This is an open source model from OpenAI.
Yeah. Question for you on this. So these are all open source models that are publicly available.
Correct.
That you can run. If DeepSeek was developed by the Chinese, if I download DeepSeek and I want to run and use DeepSeek,
yeah,
is it giving my data back to the Chinese?
No.
Okay.
So the models that we run in themselves have no capability to make external calls or to share their data. The only way that's going to happen is through the system that you're using to interact with those models.
Yeah. So if you're using DeepSeek's public cloud version, yes.
Correct. Yes.
However, if you're using the open source version that you control, it's not.
Correct.
There's no backdoors.
That's right.
Okay, cool.
Yeah. So I won't cover these too much, but you can see.
Yeah, because we can actually show them in a minute.
These all have different scores of how well they responded.
Yeah.
Okay. Happy to move to the next slide. Okay. So running, obviously we need equipment, we need hardware to run these models, these open source models, and the infrastructure that we use to utilize them. These are the precision. I don't think I touched on precision.
No.
Essentially, when models have parameters, which you can see here, the model size, between 3 and 7 billion parameters, 8 and 13, and so on. As the number of parameters go up, their size goes up. Another one of the recent discoveries was the ability to alter the precision of the weights or the parameters within those models. The lower the precision, the less information we need to store, therefore the smaller they can be, and then vice versa. The high precision, more information, larger. These models need to run on VRAM or the GPU RAM in order to work at their best speed. You can run them on a mix of CPU, GPU, you can run them on just CPU, but you are compromising performance. And then what we've got over here is a suggested configuration for Mac. So Mac with their unified memory, we're able to get a lot more RAM memory that can be utilized for the GPU. Therefore, these Mac Studios and the Mac Mini and the entry level are a really great option there. And then here's their possible use case given the size. And if you're interested, here's a comparable suggested NVIDIA GPU setup. And if you know anything about these GPUs, these are quite expensive. So for the value between 4 NVIDIA A100s versus 1 Mac Studio, I think I know which one I'm going to choose.
Yeah, so when you're configuring an open source LLM onto a Mac Studio,
yeah,
it can be just deployed on there and run without any low-level hardware configuration. But when you're using an NVIDIA A100, you have to configure the low-level hardware configuration for it to run and then install it on top with the OS. Is that correct?
Yeah, that's right.
Yeah.
So not only are you paying for these GPUs, you're also having to pay for a system that can link or hold all of these GPUs, or possibly multiple systems that run these GPUs and link them together. The complexity at the hardware level and then configuring these at the hardware level is much higher versus a Mac option.
Yeah, so the Mac can be plugged and played into a local network and shared, but the NVIDIAs need to be run on a dedicated server rack inside usually a managed service environment.
That's right.
Yeah.
As you go up in these higher tiers, the performance of these will be better than a Mac Studio. I'm not going to hide that. However, the simplicity of managing and running and setting this up is far outweighs, in my opinion, depending on the use case.
Yeah, definitely. Yes. I was talking to a local product company in Brisbane that's setting up an NVIDIA rack at the moment, and they spent the last month trying to configure the low-level hardware. So they haven't even got the benefit out of it yet, as compared to a simple plug-and-play solution. Cool. Thanks, Chris.
Okay.
All right. So looking at use cases, when it comes to large language models in AI, there's four different archetypes of use that you can think about. So framing this, this is how you can actually use the AI. So the first one is assistive. So assistive is what we're using kind of every day. If you've been using something like Claude, ChatGPT, or something like that, that enables you to chat with the AI, ask it questions, and it can quickly complete work. So it's really good for low-level work, and also optimizing repetitive patterns, and finishing your work for you, if that makes sense. The second one is agentic. So agentic is becoming more popular, and started gaining momentum in the last 6 to 8 months. Agentic AI is where you tell the LLM or the agent to go and do a task for you. So agentic is, right, I want you to achieve this objective, and the AI goes off, does the task for you, comes back and gives you the output. So you give it an input, it has a process that it runs, it comes back with an output, and that can be a multi-step process. And the third one is orchestrative. Terrible at pronouncing that. And what that does is where you basically orchestrate many agentic agents. So what that means is that it might be a multi-step agent. So what happens there is you have a trigger or a starting point, and you may have many different steps along and many different agents within that path to achieve different objectives that may have many different inputs and outputs along that workflow. Yeah. This has become very popular, probably I'd say in the last 6 months, where people are creating their big orchestrative AI agents. They're using multiple different agents within there, multiple different chat versions. And that's effectively what's happening at the moment. So it's very, very much advanced orchestration, and can do a lot of really good things. But at the same time, they are hard to manage in that it's hard to keep track of what's happening within those systems, and they can fall over. They're quite brittle. The last one is a completely autonomous AI system. So a completely autonomous AI system is when you have no observability over it. You've set it up, you've configured it, and away it goes and does that objective for you, and it figures out how to achieve that objective for you without orchestration. The autonomous ones are not yet really in market. This is a concept that's coming, and is on the way. What we're going to be showing you today in regards to when we jump over and do a quick demo is only assistive. We're not yet looking at any agentic or orchestrative environments within what we're presenting. I think that's good. So how do you measure the impact of AI? Some work done by a company called Winning by Design in the US has proposed a very simple method. And that is literally just to compare the human input and time versus the output. So compare the results of an AI-driven process against your traditional approach. Look for similar or better outcomes, and also measure the effort to produce those outcomes. So check if the cost and time are reduced, and assume the optimization and scaling can be increased for efficiency. So the best way they suggest doing this is running a simple test. So doing a time audit of how long it takes you to achieve a business task. So that might be to review a document, and have that document be summarized as X would take one person maybe an hour. And then can that be done with an AI enhanced process, assistive or otherwise? What is the time frame saved from that? So we were discussing this internally amongst my team a week or two ago. And for example, us using our local AI solution in an assisted manner takes blog writing down from about probably a 4-day process between drafting, research, drafting, feedback, and then specifically in my case, grammar and punctuation, and then publishing, to probably about a half-a-day process. So the time saving on that is very significant, which is enabling us to do more, which is probably why we all feel like we're more busier.
Yeah.
It's like the benefit of email versus actual mail. You had to wait for the mail to arrive, but now it's just arriving straight in your inbox. So that's how to measure the impact of AI. I would encourage everyone to have a think about what are some of the tasks in your organization that you could use AI on and go, right, let's do an audit of how long this actually takes us. Let's experiment with an AI. And then re-audit how long it takes us. Has the quality improved? And how long has it saved us? And that is the impact delivery. Yeah. The next thing is an adoption framework. So one of the most important things to have in your organization is a policy on how to use your AI. And the second most important thing is training people on that policy. So at WorkingMouse, we have a responsible use of AI policy that's in our ISO 27001 accredited information security management. And I wanted to call out a couple of things that we included within that policy that people might find valuable when they're writing theirs. So the first one is that AI supports, not replaces people. So for us within WorkingMouse, there has to be human output and review of any outputs from AI before it is delivered. So that's basically, right, we're not going to build a system that completely orchestrates writing a blog and then we don't review it. We can build a system that orchestrates writing a blog, but we have to make sure that we're reviewing it and we're checking it for any hallucinations and facts. The second thing is that privacy always comes first, and it must follow our internal privacy policy and our data classification rules around what is public, what is restricted, and what is confidential. And responsible use is mandatory. We require risk assessment against the ethical standards within our ISMS before we implement anything into production. So really recommend thinking about, firstly, what is your stance? What is your policy? The next thing, if we move to the next slide, is training. So within our group, we make sure that every single person goes through annual training around our policies and procedures, and we actually audit that we've actually put everyone through that training process. The picture there is literally just a Kanban board of everyone's start where they've been up to on their different training schedules. So ensuring that that person has gone through the training, has validated that, yes, you have actually completed the policy training, if that makes sense. So there's two strong recommendations that I would advise to take away to consider the use of AI policy. All right, what's next, Chris?
We're going to kick into the demo. Before we do the demo, I'm going to quickly cover our environment setup and this information diagram here. So I have to look at my screen. There we go. So we start with the employee using their browser, and they make a call to the platform that we're using internally to run the models, which is OpenWebUI. It's an open source tool, so all the code of how it works is visible. We can make sure that it's not phoning home or sending in any information out. It then communicates with a number of internal sources and tools that are also open source. So, for example, one that does private web search, one that's responsible for converting the text result into speech. This is optional. One that's used for processing documents into a format that the LLMs can use efficiently. One which is using for managing those. We use a database for storing the processed documents. There's a cache to improve performance and reduce repeated tasks. You have your files and your data shares already available wherever you're storing them, whether that's SharePoint or you might have a local file store in your Office network. These are uploaded into OpenWebUI for processing and for storage using a number of services available, such as the vector database. And then we use a tool called Olama for managing and actually performing the inference on those models. And of course, the only thing that goes out of this system is the web search. And yeah, again, this never actually sends out your private data or your private knowledge. Only, you know, whatever search query it puts together is what gets put in the web. And that's more likely going to be whatever you would type if you went to Google. All right, so let's have a look at OpenWebUI this way.
You just explain the domain and where this is hosted and how they log in.
Yep, I'm just going to switch. I think light mode looks better in the web. Okay, so this is OpenWebUI, and we have it served at one of our domains here, which is ai.eastcottage.industries. This is an internal domain name only, available only from our office network, which means this can't be accessible from any external networks. Our teams and employees all have VPNs set up on their machines, so they are able to access our work office network for our internal services, such as this AI platform. Okay, so this platform should look fairly similar to something you may have used before for AI. Looks a little bit similar to ChatGPT, I would say. So we have over here on our left, we can start a new chat. That's where I am right now. So it's telling me the model that I have used, and I have my big chat prompt here in the middle. I can change the model that I can talk to through this drop down here. We've got a couple loaded. You can see the number of parameters they have that we've been given. We've given them some labels, so we have some extra information as well as a description. And down the left here, we also have the history of our chats. We can go back to these chats and click on them and see the results. So here I was talking to GPT OSS Large, which is the 120B model. And I asked it this question with this prompt. It did a little bit of thinking and then gave me this response. Pretty straightforward. I thought this was an interesting response. For me, it was a bit too long. So I asked it effectively the same thing again with 2 words difference, be concise, and then I got this result. A vastly different result in terms of length, but actually the answers here align very well with what it originally suggested and what I would expect from this particular prompt. So this is just basic prompting a model, right? It's using its own internal knowledge, if you will,
when it was trained.
From when it was trained. Yes, thank you for clarifying, Dave.
Yeah.
To give me this response. Now, you can see down here, I also have web search. I don't need to talk about code interpreter today, but I also have the ability to attach knowledge. So first I'm going to talk about web search. I was interested in keyboards, computer keyboards for gamers. So I said, you know, I'm looking for a computer keyboard. Give me 3 options based on price. I'm interested in quiet but a smooth feel keyboard, and give me prices where available. So it's gone and performed 5 web searches here. So what it's done behind the scenes is converted my prompt into some search engine queries, performed those queries, evaluated the response from those queries, and found these 5 results were probably the most appropriate. I then did some thinking, which you can expand and see here, and then finally responded and included its citations of what it included in its response down here. So I can expand these out and see the information that it got back from its particular source and that content. So this was provided back to the LLM to form its final result, a response, which is what it gave me here. 3 smooth feeling gaming keyboards. Yeah, So that's using web search. I can do something similar using knowledge. I'm going to do this one as a live demo. And yeah, I'll leave this model here. So I have preloaded into knowledge the YouTube video transcript from the latest Apple event. So I'm going to load that Apple event knowledge here, which I've pre-uploaded the transcript. Actually, I'll show that really quickly. In my workspace here, I've knowledge, which is this collection Apple event. In here, I've uploaded this file, which is the transcript from that video. Okay, I'll touch on permissions at the end as well. So here you have this transcript. You can even click on it and see, yep, that's my transcript content. Okay, new chat, Apple event. Let's say what's something that would interest you, Dave?
What is the difference between the two new watches? Should I buy the Apple Watch or the cheap one? I'm literally considering that. Yeah.
Should I buy the...
Oh, I can't remember the cheap one.
Let's just ask this question, right? So I passed in my collection here, which has my video transcript in it, and let's see what comes back.
Will it take a minute to warm the model up?
Yeah, it looks like, oh, it might take a minute, yeah, just to load the model back into memory. So yeah, here we go. As part of our system, we have it kind of put the models to sleep when they're not being used. This is to allow other models to be loaded up when they're needed. And also just to save on system computes and electricity costs. And you can see which ones are loaded by this little green icon here. Yeah, you can see they unload in 30 minutes of not being used. So now it's loaded, I can continue to talk to it and it will respond nice and quickly. So yeah, Apple Watch SE3 versus Apple Watch Ultra 3. Both of those were announced at that event.
But there was also another one announced. Yeah, close.
You can see the citation here, and it's pulled out this particular portion of the transcript and used it. Oh, there's actually multiple here. Provided these portions of the transcript to the LLM to form its final result. We can have a look at the thinking here. Yeah. Cool. So that's using a model with knowledge. You don't have to preload it into knowledge. That's if you have knowledge that you're going to reuse over and over. So a good example might be if you loaded in your company's policies and procedures that enables an employee to go and perform searching or querying across those policies and procedures to find out what might be relevant to a certain situation or what process they should follow.
Or how to achieve a process, yeah.
Or how to, yes.
Yeah. Probably just access some permissions, then we should get on 10 minutes back at lunch.
Okay. Yes. Okay. So the system also has pretty good control for access and permissions. So most of the things for users, as you see here, will be, look at my screen, will be private by default, which is only for yourself, or if you select groups. By default, there's no groups, and we have no groups set up at this point in time for the demo. However, that's how I can limit this. I might create a group which is for
Solution architects.
Solution architects, yes, there we go. And I've uploaded a bunch of documentation on how to build, good systems, or how we have decided to follow certain principles and practices. Enables our solution architects to go and query them, find information.
Yeah, we wouldn't want anyone else to know that much.
It's just an example they can take. And here you can see, because my demo user is locked down, I can only use the private option. In an advanced, for an administrator, they can actually make certain knowledge public. So your company policies and procedures would be perfect to make public to all of your users.
Cool.
So we can do the same thing, not only with knowledge, but also with models. So you might only want 1 or 2 models given to these users here, or these particular models given to these users. It's really helpful to allocate them that way, considering there's a lot of other ways to configure and set up models.
Yeah. All right. Thank you very much, Chris. Excellent demonstration. We're running 5 minutes over, so we might just finish off the presentation there and open it up to see if anyone on the webinar has any questions. Feel free to put them in the chat, or unmute yourselves, or put your hands up even. It's all right. See if anyone has any questions.
I've got one.
Yeah, Mr. Burrows, hello.
Yes, how you going?
Yeah,
So
good.
all these, the basic, the models that you install, there must be huge databases, right? What sort of capacity? There must be terabytes, right?
Gigabytes, not quite terabytes yet, but the large models can be
It shows you on the thing, doesn't it?
Yeah, I think it did. There was a slide with that.
Not here, but inside this shows you the database size.
Okay, and then as you start to, it must record preferences and it must record responses, and as it learns, I suppose, it must then those databases must balloon, right?
No, so your communication, or even your team's communication with the models, does not go back into the models themselves. So this size here won't change. This is the size of all of the parameters and weights of the model.
Yeah, right.
What you can do is the settings, personalization. You can manually enter memory in here, which is information about yourself, or the way that you would prefer for the models to respond. For example, for myself, I say I want Australian English, please. Australian grammar, Australian spelling.
Yeah.
In the future, I believe this, because this is still an experimental feature, this might end up becoming automated. So it will, in your communications, it will remember a fact about you and store it here. But this system is designed, OpenWeb UI is designed to be your privacy controlled. So anything that it does start to record about you, you could come through here to manage and change.
So that's how you control your personal questions and knowledge on you.
Yeah.
You can also set, when you're setting up the knowledge base of the model, you can ask it to respond differently within that knowledge base in the context. So if that's for your general chat preferences, but within a knowledge base, so you can configure the system prompt, we call it, within that knowledge base. So in the system prompt can be talking about this knowledge. I want you to only reference this knowledge, and I want you to act as this and respond like this.
Yeah.
Yeah.
Thanks.
Good question. Thank you, Malcolm. Anyone else? No? Cool. All right. Well, oh, sorry.
I put one in the Q&A. I was just wondering, so when you are using, asking questions and things like that, how do you determine which model is the best one to use?
Also a great question. A lot of the times it will come down to your experimentation and your personal preference. You will have found that when using ChatGPT, for example, you found, hey, this model here was good for writing blogs or, summarizing content. This one over here was good for, asking technical questions about systems or about processes or something like that. So what we've done for our teams is try to put a description on these models to help indicate and speed up that process. So you can see the size and what it might be best capable at, and whether it's a fast or maybe a slower but more of a deep thinking model. The smaller models will typically be nice and fast, but it'll be a less in-depth or a less accurate response. They're good for iterating nice and quickly. The larger ones, like this one here, the Llama 4 Maverick, They'll take a little bit longer to respond, but the answer will be of a higher quality.
Definitely.
Thanks.
Thank you.
Cheers, Dave.
Thank you very much. All right, appreciate everyone making the time. Thank you so much. We will send out a copy of the recording for everyone, and have a good afternoon.